Okay, good day, class. So, there are five lecture notes, no? These are the remaining topics, pero mugbo naman yung ubang class. Ako lang siyang striton o discuss, dayan. Ang uban putlon-putlon siguro na ako para dili na kayo ma-overwhelm. Pero depende lang. Okay? So, let's start first with natay nabilin ng mga derivatives class na wala na discuss. Pero, kuan naman ni siya more on unsa lang yung derivative but the idea or the concept remains man. Kabalo naman mo mag-differentiate, no? So that won't be a problem. Medyo ma-add lang ni sa inyong memorization. Okay? So for derivatives, three ka lecture notes ang kuan ani, lecture 16, 17, 18. So let's discuss the trigonometric and inverse trigonometric. Actually, pwede ra gani ko na dili i-discuss kay hatagan nito mo sa iyahang derivative sa mga trigonometric ug inverse para kamo na din mag-solve. Kabalo man mo sa idea. Pero kining logarithmic ug exponential ako na i-discuss and hyperbolic functions. So mag-scan na to gamay class ang sa trigonometric, okay? So for trigonometric, if you remember, naa sa inyo I forgot what lecture that was katong sa last slide niya nga nakatabulate dito ang iyang mga derivative, no, but for review lang we have derivative of sine, we have cosine na familiar mo na, then kung cosine, negative sine, and so on. Okay, di na ako basahon tanan. And then for inverse trigonometric, kini medyo tricky kay when you say inverse trigonometric class, ako lang nag-emphasize po din nung when you say arc sine, no? Or inverse sine, pagbasa na, inverse sine of x. We do not refer to the exponent dili kining -1. Okay, this is not the exponent. So meaning, when you have this inverse sine x, it is not equal to sine x raised to the -1. Ano naman, because sine x raised to the -1 is 1 over sine. Okay, kung negative yung mga exponent, di ba mo na? And 1 over sine is cosecant x. Okay? Pero nga dili siya equal because when we want to get the inverse sine, we are getting the angle, ana. Okay? So, pasabot ana, when you have, for example, inverse sine, I think na-discuss na rin sa mga previous lectures na to. For example, you have inverse sine of um, 0, for example. Okay? Meaning, unsa man nga angle class, nga ang iyahang sine or ang iyahang y coordinate is 0. Okay, so again, adto mo sa unit circle. So kung iyang sine or ang iyang y coordinate nga equivalent is 0, unsa ka ni nga mga angle? Of course, kini nga mga angle na sa imong x. It could be 0, it could be pi, 2 pi, 3 pi, and so on. Okay, mo na pasabot sa inverse sine. Okay, lahi na siya sa imuhang 1 over sine because 1 over sine, you will get the value of the angle. Okay, kini siya is angle mismo atong gipangita. Anyways, unsa man kaha ang ato ang derivative ana. Okay, so ingani ang given class. If you are given arc sine and you are going to get the derivative, ang derivative ana class is 1 over square root of 1 minus x squared. Okay? Again, di na ako na isa-isahon, no? Ang difference na class for cosine kay negative, dira. For tangent, kung ano na nimo. Actually, dali na po ng tangent kay kung nakakaani class. All you have to remember, kani ra dyan duha, no? Because the other ones are just gikan ligya po na ng cosine o sine. So for tangent, you will have sine over cosine. So if you try to solve that one, you will get 1 over 1 plus x squared. Kung cotangent, inegate lang nimo ang imong tangent. Okay? For secant and cosecant, medyo na siya extra. So kani siya x squared minus 1, kini 1 minus x squared, no? And then naka-absolute value of x dira. Okay? So, again, ang akong tip sa inyo to better memorize this is to solve a lot of problem involving these inverse trigonometric functions para mas maalad mo. Okay, let's have an example. Review lang taga-minus sa trigonometric before we go to inverse. Naagian naman ni nato tanan pero it's good to review lang. Okay, so if you have g of x is equal to 3 secant x minus 10 cotangent x, what will be the derivative? No? So g prime of x will be 3 times, okay, ang derivative ani. So refer to the table, that would be secant x tangent x minus 10 derivative ani is negative cosecant squared x. Okay, and then just simplify. Okay, next problem, we have h of w. 3w to the negative 4 minus w squared tangent w. Okay, so medyo bag-o sa mata, no? Pero ayaw lang mo kalibog kung gi-change ang variable kay the same concept or the same rule applies gyapon. Okay, so h prime of w, that would be 3, okay, morning constant, and then get the derivative. Okay, so bring down negative 4, and then kini minus sa nimog 1, so that would be negative 5. Minus, kini, you will use product rule for this. So copy w squared, get the derivative of tangent, that is secant squared, plus copy tangent and get the derivative of w squared, that is 2w. And then, again, you will simplify. O, di naman further masimplify, no? Kanina naman siya tanan. Okay, next. We have 5 sin x cosine x plus 4 cosecant x. So, kung nakay duha, product. Pwede, akong giingon before class, pwede ang 5 ikuyog di mo sa sine, pwede sa cosine, pwede sad nga, imo sa siyang ipagawas daan, no? Ay lang mo kalibog, basin, lalagyan ng approach na, you will get the same answer. So, ipa-dapli sa lang 5 dira niya, i-enclose na to na siya for emphasis nga kani siya ang gigamitag product rule. So, copy sin x, get the derivative of cosine, that's negative sine, plus copy cosine, then get the derivative of sine, manang cosine x. Plus 4, niya, ang derivative of cosecant is negative cosecant x cotangent x. Again, refer to the table, to the list of derivative for trigonometric. Okay, so we now simplify. So you will have kini kay negative sine squared, no? So ato na siya ibalhin kay kini positive man ni. Unahan na tulad sulat ang positive. 5 cosine squared minus 5 sine squared minus kanina dayon. Okay, so next, let's have sine t over 3 minus 2 cosine t. Okay, so lengthy lang siya gamay kay naggamit ang product rule, but kabalo naman sa na class. You have low d high, low, okay? Derivative of high, so cosine, minus high, d low, okay, ganun siya, over low squared. And then simplifying that, now, kung naka-trigonometric function class, pangitawan gid mo or dapat aware ka sa identity nato. Ang identity nato is that you have cosine squared x plus sine squared x is just equal to 1. Okay, para mas masimplify. So that's why nakakuha ta gingani class. After simplifying this one, nakakuha ta og cosine squared t plus sine squared t. And from this identity, that would be just equal to 1. Okay, so that's why we have this final answer sa imong p prime of t. Okay, dagag identity gyapon sa trigonometric class, pero kani ang pinaka-common. Okay, if you remember. Okay, and then I also added link to kuan. Pulse notes man siguro ni siya. So that you can practice. Okay? So i-click na yung link dira, you'll have more problems to solve for trigonometric. Okay, let's go to inverse. Duha lang class just to emphasize on pag-differentiate, pero kabalo naman mo na again. So let's have f of t is equal to 4 inverse cosine of t minus 10 inverse tangent of t. So that would be f prime of t. Again, pareha na dyan siya tanan class. Ang rule niya, it's just that dapat makabalo ka sa iyahang derivative ani. Okay? Inverse cosine will be -1 over square root of 1 minus t squared. Okay? Kung sa variable mo, sa may button dira kay basin dito x gyapon ni diri. Okay? Ayaw. Kung sa variable dira gamiton, mo pa rin gamiton dira. Okay. Minus 10, nya ang inverse tangent nato will have this derivative 1 over 1 plus t squared. So simplifying all of that, you'll get this expression. And then finally, we have square root of z, inverse sine of z. Okay. So consider man nga duha no, duha ka equation. So again, ato lang ning express into exponential, that would be z to the 1/2. So copy z to the 1/2 and then get the derivative of arc sine or inverse sine. So you will have 1 over square root of 1 minus z squared plus copy, kanina pa rin may copy, and then get the derivative of z 1/2. Mo na siya. Okay. And then simplifying, you'll get this expression. Okay, so that would be all for derivative of trigonometric and inverse trigonometric. Let's proceed to exponential and logarithmic function. Okay, so exponential function, kasi exponential function naka-exponent siya, no? Dili number ang exponent class. Ang exponent is the variable mismo. Okay, so dira ta makaingon ni exponential ang imong function. So for example, nakoy y is equal to kuan lugar x squared, no? Abi kay exponent anto makaingon kay exponential, dili na exponential. Exponential again is when your exponent is the variable para saan eh, okay? Given by this expression. So, generally you will have y is equal to b, hindi ko kaklaro. Okay. Okay, y is equal to b to the x. This is your exponential function. Ang x na to plus nga variable mo na itong exponent, okay? And b is a constant number, okay? Now we have a special type of exponential function. Gitawag na itong natural exponential function, wherein your b here is equivalent to your e, natural number nimo, which is equal to 2.71828, kidagan na siya. Okay, this is a more general exponential function. One type of that special type is the natural exponential function, where your b is equal to e. Now, kung ato na i-convert to its logarithmic function class, kabalo naman mo no, ang atong b diri mo na tong base, ang atong y is kani siya, and then i-equate na siya sa imong variable or katong exponent nimo. Okay, so this is how you rewrite or convert your exponential function to logarithmic function. And then, nasa tay, gitawag na natural logarithmic. Kung naatay natural exponential function, nasa tay, natural logarithmic function class, where your b, again, is equal to e. Okay? And if you have this expression, now you're familiar with this, I hope so. If you have log of base e, pwede na ito na ma-rewrite to ln. Okay? It just denotes that the logarithmic function is a natural logarithmic function. Okay, ln. Again, ang ln nimo class is a special type of logarithmic function where your base is e. So for example, na kay log of y nya base 2 is equal to x, dili na mo pwede ma-ln y is equal to x. I mean, dili mo siya pwede ma-rewrite in this way. Okay? Ang ln man nato denotes that your base is e, log. Okay? Ana. Okay, so let's go to okay. Karon class, kabalo na ta no? That's the exponential function. Exponential function gyapon ni class ha. Ang imuhang b to the u. Pero mas gi-general na to. Such that your u is a function of x. Dili na lang siya x lang, no? Pwede siya b to the x or b to the, example, x plus 2, inana. Okay? Basta, it's a function of x. Okay? So, this is a more general nga expression. So, unsa man itong ipangita diri? Atong ipangita class is the derivative of an exponential function. So, the derivative class of an exponential function is very easy. That would be derivative of b to the u, no, where u is a function of x. All you have to do, class, is copy b to the u. Okay. Copy b to the u. Get the derivative of u prime. Okay, multiply na siya. And then, lastly, i-ln mo ang imuhang base. Kana, lnb. Okay, again, this is the general expression for the derivative of b to the u. So that is bu, copy b to the u, times u prime, okay, whatever function dira, and then multiply by lnb. Now, take note nga, ang b man good nimo class is a constant number. Therefore, kaning lnb, it will also be a constant number. Pero, when you write sa inyong final answer, pwede ra ma-retain. For example, ln2, pwede ra na i-retain. Ayaw na siya i-decimal or whatever. Okay, pwede ra na siya. Unless if it's a special value, for example, 1 or 2 or whatever. Okay? Pero ln something, ln number, okay lang na siya i-retain sa pagsulat sa final answer. Okay, so if this is the derivative of b to the u, what is now the derivative of b to the x? B to the x, of course, gikan na siya diri sa imong b to the u, where your u is equal to x. Okay, so kung i-follow na to diri class, ang ato ang derivative di, what will be the derivative of b to the x? Copy b to the x, okay, multiplied by the derivative of u, which is the derivative of x, and that is 1, okay, multiplied by 1 lang. Multiplied by ln b, ln sa imuhang base. So, the answer would be, of course, ma-eliminate na ning 1 diri, no? Kay 1 naman lang siya. So, the final answer would be ln b, b to the x. Okay, so, alam mo kalibog, maskin b to the x or unsa ba na, basta, all you have to remember is this. Okay, bali-baliho na class, kung kabalo ka ani, kabalo jud ka unsa, maskin unsa pa na, x pa ba na siya, x squared ba na siya, x plus 2, 2x plus 1. So, it doesn't matter as long as you know how to differentiate that. Okay, let's have an example. So, gisulat lang ako diri inyong for you to kanang have dani para mas ma-remember ninyo while gasolve ta diri. Okay. Let's have y is equal to 2 to the 2x. Okay? So, ang ato ang ito na yung class. If you have y is equal to b to the u, then in this case, ang ato ang b class is 2. Okay? And then u na to is 2x. Now, pambata mo na siya isulat ang ginaan ni class. Para lang makita ninyo ba? Okay? You will have this expression. So, meaning, given ani sa man, copy b to the u, okay, irisan sa ko na kiba, mas malibog siya. Copy b to the u, okay, copy ho na to tanan. So, that's why you have 2 to the 2x, okay, and then get u prime, okay, the derivative of 2x, the derivative of 2x is 2, okay, and then ln b na dayon, ln of this base, so ln 2, okay, and then simplifying that, you will have ln2, pwede na ipakilid diri class. Okay, that's a constant. And then, since you have the same base class na 2 dire, pwede na to i-add ang exponent, correct? So, you will have 2x here, and then you will have 1 here. So, if you combine the exponent, kay kung same base siya, di ba, plus ma-plus atong exponent. So, you will get 2 to the 2x plus 1. Okay. So, that's very easy. Okay, let's go to y is equal to 3x. Okay, copy 3x. Get the derivative of x, mo ng 1. And then, ln of this base, 3. So, you will get ln 3 times 3 to the x. Okay, third problem. 5 raised to x squared plus 1. Okay, so, copy. Copy b to the u, mo na siya. Copy na to tanan. And then, get the derivative of the exponent. So, the derivative of that is 2x. And then, times ln 5. Kani. Okay, you will get, pwede i-rearrange, no, 2x ln 5 times 5 raised to x squared plus 1. Okay, that's pretty easy, class. Let's move on to the special na dayon nga function, which is the natural exponential function. So, kani siya, kato ganina, you will have, ay, diba, anak man to, no? And then the derivative would be copy b to the u times u prime times ln b. Okay? So, same rule applies, class. It's just that ang b na to karon is the natural number e. Okay? So, the derivative of that, okay, will be e to the u, copy, and then times u prime, parehas no, times ln e. Now, karon class, ln e, if inyo na i-calculate, is just equal to 1. Nga naman, kay di ba, when you say ln, okay, balik ta sa ako ang kuan ka ganina. ln, mao na akong butang dira, ln would be, when you say ln, that is log, di ba? Log base e. Okay? Now, e pud na siya dira. So, meaning, e pud na siya. Now, ang pangutana na yun, unsa man nga, unsa ka high exponent, ang pasabot man gud ani, di ba? Pangitaon nimong exponent sa e, para mahimo siyang e. Okay? Nga naman ang pag-interpret nato sa logarithmic function, di ba? Unsa exponent sa e para mahimo siyang e? The answer would be 1. Okay? So that's why kani siya, that's why kani siya class is just equal to 1. Okay? So, if you get a derivative di of e to the u, is just equivalent to e to the u times u prime. Okay? Again, kung daghan na kayo mag-memorize, pwede na di mag-memorize, basta kabalo mo ani. Okay? Pero it's so easy to kuan class ma-embed na sa inyong mind kining e to the u, e to the x. Okay? So, muna ni siya no. Because we know nga ang ln e kay mahimo ra man ng 1, so ma-shorten pa gid ang ato ang derivative sa e to the u. Now, what will happen if ang imuhang u kay naka-x? So, mas masayon pa gid siya, class. So, the derivative of that would be e to the x copy times 1, because that is a derivative of x, times ln e. Unya, kabalo man ta nga 1 man ni siya. So, meaning, 1 pod na, 1 pod ni, so ang mabilin na is e to the x. Okay? So, ngunit pinaka sa yun nga derivative expression sa derivative class. Kay, the derivative of e to the x is itself ra gyapon e to the x. Okay? So, dali ra siya naman. Derivative of e to the x, e to the x. Kana ha, kung x, dili pwede e to the 2x. Dili na siya mao. Dili na siya. Okay? Basta kayang e to the x, e to the x yang yahang derivative. That's why, class, na kay mga memes. Don't know if you've encountered this meme, but at least karon ka relate na mo. Kani siya, when you derive e to the x daw, di ba, mag Spider-Man sa multiverse, or kani siya nga meme, parihara gyapon daw. I think she is a addict and says, I will change him with my love. So, kani siya, derivative, differentiation daw ni siya, and e to the x, maura de gyapon. Okay? So, daghan pa kay meme anak class, pero the idea is there. If you get a derivative e to the x, it's just equivalent to e to the x. Okay, let's have 3 examples. Okay. So, y is equal to e to the 3x. So, manang giingon, dili na siya equal to e to the 3x diretso. Ano naman? Okay. That would be, copy na, no, pares, dili ba, ano siya? E to the u times u prime. Okay. E to the u, okay, copy, times derivative of 3x, that is 3. So, that would be 3e to the 3x. If 8 plus 3e to the 2t raised to e to the negative 3, ato sana i-simplify, kaya you will have the same base, so atong i-combine iyahang exponent para dali ato ma-differentiate. So, when you derive that, 8 will become 0, and then this one will be copy, okay, copy, multiplied by the derivative, 2t minus 3, so 2. Okay? So you will get 6e to the 2t minus 3. Okay, so next, negative 1/4 e to the negative 2 minus 4x. So, okay, pakilda na ito ng 1/4, negative 1/4. Copy, copy, okay, copy. And then get the derivative of this. You get negative 4. So, cancel negative 4. You will be left with this lang. Okay. Next. Kini siya is properties lang class of natural exponential function. So, itsura na to sa exponential function class is like that, no? So, kung tanaw na to, ang domain na to class is from negative infinity to positive infinity. Pero ang atong range is from 0 to positive lang, no? Wala tayong negative nga value. Nga naman, kay dili man na negative ever imong e to the x good. Maski negative ang imong x, for example, e to the negative 2. That is just equal to 1 over e squared, di ba? And this is a positive number. Gihapon. However small, pero it's still a positive number. Okay? So, mao na imong range is from 0 to positive infinity. Nara dira. Okay, it is continuous, increasing, and one-to-one in its entire domain. And then it is concave upward. And then another property is yung limit class. Limit of e to the x as x approaches to negative infinity is equal to 0. Nga naman, kikatong ganina, 1 over kung negative ang imuhang x, no? Example, negative infinity man na, no? So, that would be 1 over e to the infinity. And this is a very, very large number. So, if this is a very large number, then this will be a very small number. So, which approaches to 0. Okay? Kini siya, e to the x. Kung ang x nimo approaches to infinity, so kung nakay e to the infinity, dako po kayo na ang number na it is infinite gapon. So, mo na pasabot sa limit niya, class. Okay. Let's go to LNU na derivative, logarithmic function. Okay? Dali ra po gani class, pero more practice lang, no, kay usay ra mamabali na sa estudyante. Okay, so when you have LNU, where u is a function of x, no, what will be the derivative of that? So, dali ra kay class. 1 over u times u prime. Mura na siya. Bali, mawala na yung ln diha nga expression. Okay? It will be replaced with 1 over u. Okay? 1 over u, again, sorry, balik-balik ko sa again. 1 over u multiplied by u prime. Okay? That's all you have to remember. So, kung nakay ln x di class, that will be 1 over x, okay? Multiplied by u prime niya. U prime mo is imong x man, okay? U prime is a derivative of x, meaning that is just 1. So, maunang if nakay ln x, 1 over x na nang iyahang derivative. Okay, dali ra siya i-remember. Okay. What if ang imuhang base is not e? Kani siya ang ln x nimo klasa, again, balik jud ko ani para ma-emphasize. That is equal to kana, di ba? Log of x to the base e. Pero what if imong base is b? So what will be your derivative? No, so yun na kay class. That will just be equal to before na ko ni hatag ato sa tan-aw nga ani siya. It's because your log of x to the base b, kung panggamitan nato og property sa logarithmic, is just equal to ln x over ln b. Okay? So, I think you need to review properties of logarithmic. Pwede na mo ma-express. So, for example, if naakay log 10 niya 2. Okay? Log 10 to the base 2. Kung ato na siyang i-relate in this expression, pasabot ra na class is ln x over ln 2. Si x, ln 10. Okay? So, kung i-calculate ninyo class, pwede ninyo i-try sa inyong calcu. Log 10 base 2. Then, i-check ninyo if ln 10 over ln 2 equal ba. Okay? And that will be equal. So, okay. So, what happened? What happens here is that when your ln x over ln b, kuhaan na mo og derivative, your ln b class is a constant. So, di ba kung constant, pwede natin ipakilid. And then, ayan na to, kuhaan og derivative ang ln x or katong sa itong variable. So the derivative of ln x is 1 over x. Tama. So that will just be equal to 1 over x ln b. Okay? That is for base no nga dili natural number kung nakabilang ka dira. Okay? So dali naman siya yung 1 over x niya nari kay extra nga ln b sa ubos. But again, your ln x will be 1 over x. Okay, so these are the logarithmic properties. Okay, we have ln 1 is equal to 0. Again, unsa kaha nga sabot ani unsa exponent sa mong e para mahimo siyang 1, di ba 0? Okay. ln of ab, ang pasabot lang ani if you're enclosed with parentheses, pwede na mo i-write in this way, ln a plus ln b. Okay. If ln a to the n, pwede nimo ma-write as n ln a. Dili na ni sa logarithmic class no, pero oh, wait lang ha, loading ko. Oh, okay, yes. So, ang imong exponent diri class, pwede na nimo ma-bring down. If it complicates your solution, then if it's better to bring it down ng n because equal naman na siya. Okay. ln a over b, lahi na siya sa katong ln ko ha, ln x over ln b. Dili na siya the same ani. Kaya siya kay gi-enclose mo na siya, ay siya gi-kuha ln. So that would be equal to ln a minus ln b. So that will prove to you useful class if you solve a lot of problems na involving different logarithmic properties nga makapa-easier sa imong differentiation process. But anyway, let's have an example. Okay, so recall no, kani nga property niya ang derivative of ln u. So that is 1 over u times u prime. Okay, so okay, here we have ln square root of 3x plus 2. So, pwede na ito ni-express to 1/2. Yan, napay kulang nga step, class. No? Imagine lang ninyo. Ato na ginaog ang ato ang 1/2 dira. Dayon, ln of 3x plus 2. Okay? So, kung ginaog na ito na, by virtue of this property, we will get 1/2 kung magkuha na tag y prime. So, pakilid ng 1/2. And then, ang ln yun mo, that is 1 over u. If you differentiate, so mo nang 1 over kanara multiplied by u prime. U prime is the derivative of 3x plus 2, and that is 3. So, you will get kaning expression for y prime. Okay, next. Ln of x squared plus 2x plus 3, that is 1 over, yes, kani 1 over u. So, 1 over x squared plus 2x plus 3, and then the derivative of this one, u prime. So that is 2x plus 2. So, ang answer would be this expression. Okay, we have ln x raised to 4. Kini siya, mura ni siya og katong general, we use the chain rule, di ba? So, bring down 4. Okay, bring down 4. Dayon, kini minusan ni mo 1. That's when mo siyang 3. And then get the derivative of ln x. Okay. Ang rule sa atong differentiation class, wala ay nagbago. Okay. So ln x, the derivative of that is 1 over x. Okay. And then simplifying, you will get this expression. Okay. Okay. So mo pa na the properties sa natural logarithmic function. Ang imong exponential, if you remember paana, no? Logarithmic na to is paana. Ang domain niya class, different from your exponential. Ang domain is negative infinity to positive man ang exponential. Kini siya, it's just from 0, okay? 0 ra na siya, no? Wala kay negative, wala kay value diri sa mga negative x. So 0 to positive infinity. And then your range is from negative infinity to positive infinity. Okay, continuous yapon, increasing, and 1 to 1. However, kung nakita ninyo yung graph, it is concave downward. Okay, so let's have one last example, ay 3 di. Okay, so let's have e to the x ln x. The derivative of that is, magamit taog product rule. Okay, copy e to the x, the derivative of ln x, that would be 1 over x. Plus, copy ln x, derivative of e to the x ra gyapon. Okay, so simplifying mo na siya. We have number 2, 3e to the x plus 10x cubed ln x. So first is parehas ra, no? Get the derivative of this, that is just the same, 3e to the x. Plus 10, pwede pakilin itong 10. And then get the derivative using product rule. So copy x cubed. Derivative of ln x, 1 over x. Plus copy ln x, derivative of x cubed, 3x squared. Okay. And then simplifying na dayan. Okay. And then lastly, we have ln 2 minus e to the 5x. 1 over, okay, ln x man tano, so 1 over u, so 1 over 2 minus e to the 5x times the derivative na dayon, ani. So the derivative ani class is, yes, the derivative ani is negative e to the 5x kana times 5, okay, times the derivative ani. Okay, so that will be negative 5 e to the 5x kaning expression. Okay, so that's all for exponential and logarithmic function. Let's proceed to hyperbolic. I think last na ni for this group of discussion before we go to parametric and what's the other one? Partial differentiation. Okay, happy to class. Okay, for hyperbolic functions class, dali raman jud siya. Nalan siya mga extra nga HH, no? So, basin makakuan mo ba nga, libog kayo kay pareha siya sa sign pero di siya pareha sa sign. Okay? Hyperbolic is, pwede na ito tanawin din class, no? I think ma-discuss sa inyong calculus 2, pero just for you to have an idea. Ang hyperbolic function na to is, if you have a cone nga gikat in this manner, class, in this manner ha, then tanawin mo, iyang cross-section, mo ni siya nga hyperbolic, kani siya nga graph. Graph. Okay. So, kana partner gina sila sa this drawing, no, and this will make up your hyperbolic function or hyperbola. Okay, so ato ta karon sa definition sa itong hyperbolic. So, itong hyperbolic class is basically trigonometric pero na h. Okay, so for example, sine hx. Ang pagbasa na is hyperbolic sine of x. Okay, hyperbolic cosine of x, hyperbolic tangent of x, and so on. Now, duha rin mong hinumduman. Actually, pwede ra gani isa. Okay, ang isa opposite raman, and then from these two, we can get na dayon the other ones, hyperbolic functions. Okay, so hyperbolic sine of x class is equivalent to e to the x minus e to the negative x over 2. So, kanara ginimunduman, no? Pag manigate na mo dira sa tunga, hyperbolic cosine na siya. Okay? And then, ang tangent mo gikan ra na class, sine divided by cosine. Okay? You will get, kamunay ko na bahala na class. Nata example na later. Okay? So, muna itong graph sa itong hyperbolic function class. Kung tanawin mo, kaning mga broken lines class, sila na ang imaginary na siya nga mga graph, no, in which nga ma-add na to, example kining duha. Kini. This is e to the x over 2 nga graph. Okay? And kini siya is the negative of e to the negative x over 2. So if you combine that, you combine these two graph class, you will get this kind of graph, which is your hyperbolic sign. Mao nang nakay e to the x over 2 plus, e to the x over 2. Pag i-plus ni mo ani may negative e to the negative x2. Okay, tungod ani negative dire. So, that is just equivalent to this one. Okay? And so on. So, para lang makita ninyo sa itsura sa tong hyperbolic ng mga functions. Okay. So, napot yung mga identities class. In the same way na ta identity sa itong trigonometric. Diba? Kini, bali lang dyan siya class. Nalang siya mukontrol lang siya gamay sa trigonometric functions na itong identities. Kaya, if you can remember, natay cosine squared x plus sine squared x, di ba itong identity nga mag-equal siya 1? Okay, kani siya naka-minus. Okay, so again, be familiar with the hyperbolic identities. Ang gamit naman ani identities class is when you simplify your expression, na kay mga cancel, na kay mga mawala dira, na kay makombine using the identities. Okay, so mo na itong derivative class. If you remember sa itong cosine, no, cosine, derivative of cosine, that is negative sine x, di ba? Pero sa itong hyperbolic, positive. Ano, positive. Okay. So, atong sine yapon, positive yapon. No? Hyperbolic sine, that would be cosine. Hyperbolic cosine, that is hyperbolic sine, ang iyahang derivative, and so on. Actually, pare-pare lang nag-itsura class na negate lang yun ang uban. Okay, so paki-compare na lang ko sa imuhang trigonometric, no, para di mo malibog sa mga asay naka-negative, asay naka-positive. Okay, let's have an example. Proof sa nato, gamay class, nga your derivative of sine, hyperbolic sine is hyperbolic cosine. Okay, so remember, your hyperbolic sine is equivalent to this expression, no? E to the x minus e to the negative x over 2. So if you get the derivative of that class, of course, ang 1/2, pwede pakilid na to. What will happen to e to the x? You will have the same expression minus kini siya is e to the negative x, copy niya, derivative na dahil aning negative x, that is negative 1. So you will get, ma-plus man na siya tungkol no? So you will get e to the x plus e to the negative x over 2. And that is equivalent to your hyperbolic cosine. Kani. Kana. Okay? So actually, kana po po imong hinumduman, no? Para mas mahinumduman pa nimong other na functions. Okay, so let's have this example. 2x to the 5th hyperbolic cosine x. Okay, so pwede na pakilidaan 2, and then you will have, you will get the derivative na using product rule, that is x to the 5th, copy, times derivative ani, that is positive hyperbolic sine, plus copy hyperbolic cosine, and then get the derivative of x to the 5th. So 5x to the 4th. Then simplifying mo na yung answer. Okay, and then we have sine, hyperbolic sine t over h plus 1, t plus 1. So you will use the quotient rule. So low, d high, okay? That is hyperbolic cosine minus high, d low. So 1 na siya ang imuhang derivative. All over low squared, so t plus 1 squared. And then, I don't think ma-simplify further pa nino. So i-rewrite lang nato, you will get this expression. Okay, so this one, tangent x plus x squared, nag-combine na class na kahit trigonometric, basta malibog mo. Kung wala siya h, trigonometric na siya. Kini naman siya h, hyperbolic. Okay? X squared, hyperbolic cosecant x. So tangent x, derivative of that is secant squared x, plus, use product rule, no, copy x squared, derivative of this is this one. Okay? Plus, copy derivative of x squared. Okay, so that would be your final answer. Okay, and then here's some practice problems for you to solve. So, pwede rin ninyo i-compare nila yun sa, or pwede po mo magkuhan sa online just to check your answer kung mga bagyod. Okay, and then daghan po nito sa Paul's lecture notes class for different types of functions, no? Para ma-practice lang yun ang inyong kuhan. So, that would be all for under the kuan, trigonometric, inverse, exponential, logarithmic, and hyperbolic. So we will now proceed to parametric. Putlo na na ako klase kay murag sakit ra akong susundan. So see you in the next video.